So now coming to complex number, complex number and quadratic equation. Quadratic equation. Okay, it is chapter number 4. Okay, so what is complex number and what is quadratic equation? So first of all, in this chapter we will read about quadratic equation. Before, in this quadratic equation we will learn about algebraic expression, then algebraic equation, then we will linear equation, then quadratic equation. In algebraic equation, linear equation, we will also look after what is monomial, what is binomial, and what is polynomial. Okay, then we will come to complex numbers. Okay, complex numbers. In complex numbers we will read about what is complex number, complex number representation. Okay, what is complex number? Number 2, representation of complex number. Okay, number 3, argand plane, just like coordinate plane, coordinate plane. Okay, and so that's it. So in complex number we will look after quadratic equation first, and second complex number. In this complex quadratic equation we will look after monomial, binomial, polynomial, and algebraic equation, linear equation, then quadratic equation. Then we will learn about complex number, that is our topic, complex number. What is complex number? Its representation and argand plane or coordinate plane. Okay, so now first, what is monomial, what is expression first. Okay, what is algebraic expression? What is algebraic expression? Okay, suppose we have an algebraic expression. A algebraic expression is represented in the form of ax by plus c. Okay, what is algebraic expression? Any expression that is represented in terms of constants. A is a constant over here, constant a. Second, with a variable. Okay, so what is algebraic expression? We have already read in class 6 or 7 that algebraic expression is a combination of constants and variables. Example, 5x, 6x plus 2, 3z plus 6. So these are algebraic expressions. Okay, now coming to, so in algebraic expression, say 5x or 2x plus y, etc. If algebraic expression contains one constant and one variable, then we call it monomial. Okay, monomial. Example: 5x, 6y, 2z, dot dot etc. So these examples are, since it contains one constant, one variable, one constant, one variable, one constant, one, so these are these are monomials. Okay, so these are monomials. Okay, now coming to binomial. So what is binomial? Binomial expression. Binomial expression. Okay, example: 2x plus 3y. It contains two variables. It contains two monomials. This is one monomial and this is one monomial. Okay, and these are separated by a operator, either plus or minus. Okay, then it is called, when it contains two monomial, we call it binomial. Okay, now what is polynomial? Polynomial: an expression that contains more than one monomial. Okay, that is polynomial. Example: 5x plus 2y plus z. Is it a polynomial? Yes, it is a polynomial. Number 2, 5x square plus 2x plus 3. Is it a polynomial? Yes, it is a polynomial. Okay, 5x, is it a polynomial? Yes, it is also a polynomial, because it contains one or more. Okay, a expression that contains one or more than one monomial, so it is also a polynomial. Okay, so 5x is also a polynomial. Okay, so we have learned about expression. Now when an expression becomes equation, when, let's say, if 5x square plus 2x plus 6 is a expression. Okay, so can we write it in an equation form? Let's check. An equation is written in a format ax square plus bx plus c equal to 0. When an expression is written in this format, then it becomes an equation. Okay, this becomes an equation. Anything when this equal signs means equation. Okay, so whenever, suppose we write 5y plus cz plus 2 is equal to 0, is this an equation? Yes, it is an equation, because the expression 5y is a variable, z is a variable, 5 is a constant, sorry, y is a variable, z is a variable, and 6 is a constant, 5 is a constant. So it contains variables and constants. Also there is an equal sign, that means it is an equation. Okay, So these are very very important to understand what is an expression, what is an equation, and from this we will go to what is quadratic equation and what is complex numbers. Okay. So now coming to linear equation. What is linear equation? Linear equation. A equation in the form of ax plus b equal to 0 equal to c. Ax plus b equal to 0. If a expression an expression sorry an equation, okay, an equation in the form of x plus b equal to 0, this is called linear equation. Okay, why this is linear equation? Because it contains only one variable, okay, linear equation, one variable, and the exponent of variable is 1. Here x contains on x exponent is 1, x to the power 1. Okay. Second, what is quadratic equation? What is quadratic equation? Quadratic equation. Okay, what is quadratic equation? Equation in the form of equation in the form of ax square plus bx plus c equal to 0. Okay, this is called quadratic equation. Okay, why? Because in quadratic equation we know it from previous classes that when variable has exponent equal to 2, we call it quadratic equation. Okay, so since it here the exponent of variable x has 2, so this is called, it is a form of quadratic equation. So can you find the root of a quadratic equation? Root of a quadratic equation. Roots of a quadratic equation. The formula method for finding root is ax square plus bx plus c equal to 0. This is a quadratic equation. Then x equal to, if x is a root means it is a solution. Okay, solution of a quadratic equation. Okay, solution or roots of a quadratic, x is equal to minus b by a plus minus root over of b square minus 4ac by 2a. So the solution x, if x is a solution of this quadratic equation, then x is equal to minus b by 2a. Okay, it is minus b by 2a plus minus root over b square minus, it is a solution of root of the equation. Okay, this is general formula and we have to memorize it. Okay, now suppose if b square minus 4ac is greater than 0, then we get real roots. Okay, real roots, number 1. Number 2, if b square minus 4ac is equal to 0, then x is equal to minus b by 2a. This is the exact root. But if b square minus 4ac is less than 0, we get unreal roots. Okay, unreal roots. So after understanding what is linear equation, quadratic equation, then under this real roots and unreal roots, now come to imagine what is complex number. Okay, what is complex number? Complex number, it is a number in the form of a plus ib. Okay, it is a complex number. So how it is represented? It is represented by z is equal to a plus ib. Okay, so in this form we will represent a complex number. What is this I? Here I is equal to nothing but root over of minus 1. Okay, and this is the only theoretical part. We will see how it is used and how we will, why we are writing it in this format. Okay, we know x square minus 1 is equal to 0. This is a quadratic equation. Okay, this is a quadratic equation. Okay, now x is equal to plus minus 1. Okay, this is a root of the equation, but suppose we have a equation x square plus 1 is equal to 0. Is it a quadratic equation or not? This is also a quadratic equation. This is also a quadratic equation. Then what is the root of this equation? So x square is equal to minus 1. It implies x is equal to root over of minus 1. So in this case, we call it a complex quadratic equation. Why? Because we have a solution, but this expression is not real. It will give an imaginary value I, because we know minus I is equal to root over of minus 1, and where I is a imaginary number. Okay, imaginary number, and that is why we call it complex quadratic equation. Because see, in previous solution, x square minus 1, if this is the equation and it gives roots of the equation which is real. Okay, real, and we get real values. But here we are not getting real values. We get something which is not explained, or which is not realistic. So for this we are taking an imaginary value. Let's say I is that imaginary value, and we are writing I is equal to root over of minus 1. Okay, but how this will help us in mathematics? Okay, let us see how this will help. So we know if z is a complex number in the form of a plus ib. Okay, where I is equal to imaginary value, any imaginary value, Can we represent this in a coordinate axis? How we will represent? Because we know real numbers are represented on coordinate axis. 1, 2, 1, 2, okay, 3. Real numbers are easy to represent on coordinate axis. But how we will represent this in a coordinate axis? So historians have found that if A represents, if if A can be represented on a x-axis, then the imaginary part will be represented on the y-axis. So this is our representation. So the coordinate will be this, okay, A comma B. So this is the representation of the imaginary number, okay. Now there is a, how we will get the magnitude of this number? Magnitude is represented by mod, okay. Magnitude of z is equal to root over of a square plus b square, okay. So magnitude is nothing but it is the hypotenuse. This is called a square plus b square, this hypotenuse ab. So ab equal to mod of this. So this is the concept part we have to memorize. If z is equal to this, its representation is this on a coordinate axis, and the mod of z is equal to this, okay. Now coming to operation on complex numbers, okay. Operation on complex numbers. Once a addition, if z is a complex number represented in the form of this, and there is another complex number this, can we add this? So z1 plus z2 equal to a1 plus a2, simply addition, plus I b1 plus b2, okay. So this is the representation, okay, how complex numbers are added. Now tell me, can we subtraction of complex numbers? If z1 and z2 are complex numbers, then z1 minus z2 will be a1 minus a2 plus b1 minus b2. So this is the representation of, is it okay? Is it right? z1 minus z2. Let's check whether it is right or wrong. So z1 minus z2 is equal to, z1 is equal to a1 plus ib1 minus a2 minus ib plus ib2. So the result will be a1 minus a2, which is correct. Now plus I b1 minus b2. So this is correct, okay. So this is the addition of complex numbers, subtraction of complex numbers. Now coming to argand plane. What is argand plane? It is nothing but representation of imaginary representation of complex numbers on coordinate axis, okay. So let 2x sorry, 2x, let z is a complex number having 5 plus 3i. Can we represent this in coordinate axis? Yes, 1 2 3 4 5. This is 5. 1 2 3. This is 3. So this is, so this will become 5 comma 3. So now we have represented. And mod of z is equal to, it is 5 square plus 3 square, which is equal to 25 plus 9, 34, root over 34. So root over of 34. Okay, so this value OA, this point is A. Okay, so mod of z OA is equal to mod of z is equal to this. So this is a representation of complex numbers on coordinate axis, and this plane is called Argand plane. Okay, Argand plane. Okay, so now we have come to an end of complex numbers and quadratic equations. So thank you all. Thank you.